Video, we are going to talk about measures of central tendency. So that would mean the mean, the median, and the mode. A lot of those words, or maybe all of those words, you're familiar with from other classes. That's great. I do want to say something up front about calculators, is that I have a really hard time showing on this computer what my calculator looks. I mean, I can show you what it looks like, but it's really hard to see the screen. So I do have a separate video just on entering lists and getting to the screen that says how to find, the mean and stuff like that. We're going to use these lists a lot. So I will kind of talk you through it in this video, but it's better if you watch the list making video first, and then it's really quick. I think like 3 minutes. And then if you watch that first, then you'll know what I'm talking about for this. It's just I made it on my cell phone, which is easier to see my camera, or it's easier to see my calculator on the cell phone than it is on here. But then I can't take notes on my cell phone. Yeah, anyways, it's a whole thing. So jumping into 2.6a, using measures of central tendency, the center of the data can be described in two main ways, which would be the median and the mean. And the mean is also called the average, but we call it the mean here. Mean is the most common, but the median is also helpful. So we'll talk about the median more in a little bit, but right now we'll talk about the mean. So to find the mean, so here's the basic way to find the mean. Like, this is the way everybody knows how to find the mean. We're going to add up all the data values, and we'll divide by the total number of values in that data set. And so I can't find my maps. Oh, there we go. Okay, so here is our data set. And so what we're going to do is we're going to add up 1 plus 4 plus 5 plus 5 plus 5, because there's 3 5s, plus 6 plus 8 plus 9 plus 9 plus 13. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data values. So you just throw it into your calculator, you add them all up, 1 plus 4 plus all those 5s plus 6 plus 8 plus 9 plus 9 plus 13. And I like to get that answer first. So I have 65 on top, and then I'm going to divide it by 10, which is 6.5. is the answer to that one. I like to add it up first, because if you type in all those plus signs and then you hit divided by 10 and you didn't use parentheses in there at all, the calculator is only going to divide the 13 by 10, because that's the last thing on the list. And so I like to do all of it first, get that 65, and then do divide by 10. Okay, so the average or the mean of that one is 6.5. Now, something you're going to see a little bit in the homework, and this will become huge as we get into the next unit after the test, but you'll just, right now we're just kind of practicing the words. You're going to see sample, which we've talked about. So we'll have sample mean and population mean, and they have their own symbols. So the sample mean is X bar, that's how you say it, X bar, and the population mean is mu. So just to get that down, we have X bar is how you say that. And then mu, the M and U, mu is the population mean. And we're just getting used to the terminology. It's not really going to matter for anything right now. The sample mean is the mean or the average of everything in the sample. And the population mean is the mean or the average of everything in the population. So it's probably pretty easy to figure out what we're talking about here, but you're going to start to see that. So I just want you to know that it's not a big deal. So here, for example, we have plants, and there's total of 35 plants. So that's the population. It would be all the plants in the garden. However, she measured the heights of 12 randomly selected plants and recorded the data. So the sample mean is going to just be the mean of those 12. And really, you could do this without even reading that sentence or that paragraph above, because you could have counted all of those numbers to see that there's 12 numbers on that list, not 35 numbers on the list. So we're going to add them all up, and I'm not going to write them out again. I'm just going to add them in my calculator. 1 times 1.4, plus 1.8 plus 2 plus 2.5 plus 3.5 plus 4.3 plus 4.5 plus 4.8 plus 5.0, 5.3, and 6.0. That gave me 42.1. So this is the mean of the sample. So this is X bar, 42.1. And I know that there are 12 in this list. Again, you could count the 12, or you could just see that her sample had 12 in it. Divide by 12, and we get approximately, initially, this is what I'm getting, 3.508, and then a bunch of threes, but it says to round to the nearest 10th. So that's going to be right here. The answer will be 3.5 because it said, or the 0 tells the 5 to stay the same. Okay. It's not really that hard to calculate. It could get time consuming if the lists are longer, but we're just adding them all up and dividing by the number of numbers. Now, speaking of lists, you can see in the next example, we have a list, but before we get there, I want to go back and do, which one's shorter? We'll do number 1 again really quick with your calculator. I know you used your calculator. I mean, we did use it, right? You didn't add those all up by hand. Oh my goodness, I'm trying to use my new eraser button that I accidentally pushed all the time. There we go. Okay, so I'm looking at that data set. And so what I want to do, and if this doesn't make any sense, what buttons I'm pushing, that means you didn't watch the how to input list video. So make sure you learn how to input lists. But I want to hit the data button. I want to hit one variable stats, and I want to enter everything into list 1. So here we have data on my calculator is going to go into L1, and the frequency, because we haven't talked about frequency in this section yet, is going to be 1. I can try to show you, but I'm telling you, my house is so dusty. I don't think you're gonna be able to see. Yeah, you can't see that. Okay, so forget that. Watch my other video with the list. Okay, so I'm entering this all into L1 into my calculator. Oh my gosh, I didn't even enter it in yet. So I hit data first, and I'm going to enter in all the data. Let me just clear it out first. Okay, so I'm going to enter 1, 4, 5, 5, 5, 6, 8, 9, 9, 13, all into L1. Now I'm going to go to stat, one variable stats, and then use, you can't see where I'm pointing, use what I wrote over there where data is in L1, frequency is 1. And when I go down now, X bar, you might not have known what that meant in the when I was showing you how to enter lists before, but now we know X bar means the mean. And so we can see right here in the calculator, the mean is 6.5 for this list. Much faster way of entering it once you get the hang of these lists. And we're going to be using these lists a lot. So you're going to get the hang of it by the test. We're going to be doing this really fast. It's a lot faster to enter it in this way. And then also, remember earlier when we were doing number 1, I said, be careful with the division of 10, you know, with or without parentheses, it'll change your answer. There's none of that with the list. When you do it all in the calculator and you have your list all in the calculator, then you don't even need to worry about that. And so, because it has the formula programmed in. Okay, so you might be thinking to yourself, I didn't watch the list video. I don't care about the list video. This is fast enough. I don't need an extra hint, or I don't need an extra thing. It makes things so much easier. Look at this next table. We have a frequency table, and we've talked about frequency tables before. And so in this table, I have 8 pieces of information. How do I know I have 8 pieces of information in the data? Because if I add up all the frequencies, I get 8. And so this is what my list looks like. My list is, there's 3 2s, there's 2 4s, there's 2 5s, and there's 1 8. And so you have to add all that up and divide by 8. Okay, again, not terribly difficult, but in the last video, we saw frequency tables that had like 40 or 70 on the list. And so these frequency tables can get pretty big. So we're going to do the same thing. We're going to list everything in our calculator. We're going to call the data L1, on the L1 on your list, and we're going to put the frequency into L2. And when we get to that step, we are going to say that our data on our calculator is in L1, and then frequency. Last time we used the number 1, O-N-E. This time we have a frequency, so we're going to tell it, our calculator, that our frequency is in L2. Do this with me. Don't just watch me do it, because you need to learn how to do it. And it's so much easier if you can kind of do it along with me. And it's much easier if we were in person and I just did it that way, but that's not a choice. So my point is, if you do it with me now, then you'll be ready, or then you'll know if you have a question. So if you have a question, you can email me, or you can come to my office hours. Okay, so I'm going to put all my data in L1, 2, 4, 5, 8. Hit over, like I have this little joystick button, just hit over to get to L2. And I do 3, 2, 2, 1. I have all my numbers in my frequency table. And so now I'm going to go to stat, one variable stats, data, like it says over there, data L1, frequency L2. Hit enter so they're both highlighted. And then I'm going to calculate, and I can see that X bar equals 4 from my calculator. If it took you longer, if your argument is, well, it took me longer to do that than if I just added up all the numbers, it's because the data set's so small. As soon as this data set has 70 numbers in it, and we have a frequency table, it'll be much faster to use your calculator. So practice now while the data sets are small. Okay, got the mean. Now we're going to do the median, and your calculator can tell you that as well. And so we have a median. We're going to start off doing the median by hand, and then I'll show you how to do it on the calculator. It's always good to know how to do it by hand, because what happens on test day when you lose your calculator, it has a dead battery, like something weird happens. Okay, so what we want to do is we want to write, did I put it here? Oh, well, it just has a definition, doesn't say how to do it. It's the number that splits the data in half. So we have them in half smaller, half larger. That means we have all of our numbers in order lined up, and we're going to figure out where the middle of that is. And so here we have all these numbers, and they're not in number order. So if I just drew a line down the middle, I can't say that the bottom half is smaller and the top half is bigger or anything like that. I don't know, because I just randomly drew a line down the middle. We have to put the numbers in number order. So I'm going to write it up top just so I have some more room. So I have 2 40s. And then a 42, and a 48. And that looks it for the 40s. I have a 54. That's it for the 50s. 61, 65. And then in the 70s, I have 72, 76, 78. Maybe a little big. And then 2 84s. Okay, so it doesn't tell me what, or it doesn't tell me how many, so I need to count them. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12 numbers. So halfway in between 12 would mean 6 numbers on this side and 6 numbers on that side. So I'm just going to count 1, 2, 3, 4, 5, 6. Draw the line right here. That means I have 6 numbers on this side and 6 numbers on that side. And so our answer, so did you notice I drew the line in between the 61 and the 65? That's because I have half over here and half over here. So our answer is halfway between 61 and 65. So that is just the mean. So I do 61 plus 65 and divide it by 2. The midpoint formula is the same as the mean for 2 numbers. So if I add them up and I divide by 2, I see, and you might have guessed this already, 63 is halfway in between. That's it. In the next one, in the next video, or the one after that. I can't remember which one it's going to be. Coming up soon, we're going to be talking about the 5-number summary where we'll do the median again. And in that one, I'll talk about how to use your calculator. But right now, we just need to know what's halfway in between. If there were, like, let's just say there was 3 numbers. 1, 2, 3. There's our list. What number's in the middle? If there's an odd number of numbers, you just pick the number in the middle. That's the middle. There's 1 on each side. If there's an even number of numbers like this, you pick, we want 2 numbers on each side. We'd have to go halfway in between. So 2.5 is halfway in between 3 and 4. So an odd number of numbers is very easy. You just pick that one specific number in the middle. When there's an even number of numbers, then we have to do like we just did and find that middle number. Sometimes you can just look at it. You might have known 63 was halfway between 61 and 65. Sometimes it's a little trickier, like what numbers in between 71 and 86. If that was your choice, that would be a little harder. You just want to calculate it. Okay, last word for measures of central tendencies is mode. Mode is the number that occurs the most. It's the most frequent. It shows up the most number of times. So looking at this data set, it's in number order, but that doesn't matter. Well, it kind of matters. It's not in number order. This 5's over there and 5's over here. Okay, so I see I have 2 2s and I have 3 5s and everything else just has a 1. So the mode is 5. That's it. It's just which one is the most. 5 is the most. There we go. Number 6, I see 2 1s. This one's also, I just looked at the beginning and then I thought I wrote them in number order and then I messed up. Okay, whatever. Got a 6 here and a 6 here. Everything else occurs 1 time. So this answer is going to be 1 and 6. So don't at me with like the English major stuff. I know this isn't following the rules of English because which one occurs the most, you would think would be a single number. This one, 2 numbers occur the most because it was a tie. So that's okay. You could have as many numbers as you want occur the most. They just have to they have to have the same frequency. They would occur the same number of times. Speaking of frequency, let's just go back real quick to this table right here. Which number occurs the most would have the highest frequency. So on this list, 2 occurs the most because it has the highest frequency. The frequency is 3. And if you look at our list written out, you can see, okay, yeah, that actually makes sense. There's more 2s than anything else. So the mode, I'll just write it here, even though it didn't ask, we just did it. The mode for this list would be 2 because there's more 2s than anything else. Don't say 3. 3 is how many times it occurs, but 2 is the actual data value. In fact, there's no 3s. If I look at my list, there's no 3s at all. All right, last little bit is which one's better of all the 3 things we talked about. So if the data values are close together and there's no outlier, there's no number outside that's kind of like far away from the other numbers, then we're going to use the mean. If the data value has an outlier, and so, if the data value has an outlier, then we're going to use the median. So no outlier is mean, outlier is median. And the reason is the outlier, then every number gets calculated in the mean. Every number on the list. So if you have a really big or really small number, it's going to be calculated when you find the mean and it's going to affect the mean. However, in the median, you're just counting to see what number lands right in the middle. So if you have a really big or really small number, it's going to get thrown away anyways. So it doesn't really affect the data, it doesn't affect the median at all. And finally, if you have an outlier and repeated numbers, use the mode, especially the repeated numbers part. The mode would help you out on that one. Really, if we were picking, those 2 are the mode is kind of garbage. Like it's not used very often, but we will be using mean and median throughout the rest of this course. Like really after today. I probably won't say mode again. It's not really that big of a deal. Okay, so for the first one, it says liquor stores had the sales listed here, all these prices listed. What is the best measure of central tendency? So looking at the list, looking at the step, the bulleted list above, it really just kind of depends on if there's an outlier or not. If there is an outlier, do the numbers repeat? So let's just first look for an outlier. Is there a number on the list that's ridiculously big or ridiculously small? And the answer is yes, right there. 1645 is way bigger than all the others. I'm noticing no repeated numbers, or I certainly don't have several repeated numbers. So for this one, we're going to use the median because it had an outlier. Now, right now, we're being very loosey-goosey with our definition of outlier. I just said really big or really small, but you know that I don't like words like that, like what's really big, what is really small, what's a lot, you know, that kind of stuff. I don't like that. So we will have an actual definition with a formula that we can calculate the outlier. But for right now, for this purpose, it's not that important. We're just kind of using our feelings a little bit to say, does this feel really big or really small? Okay, last but not least, we have, oops, I lost my definitions. I have this list right here. There's 7 games, and it says, what should be used as the measure of central tendency, the mean or the median? And so we're already like, okay, the mode is garbage. We're already limiting it to the mean and median. And so looking at this list, are there any outliers? And this is why I like having definitions for things, because you could kind of argue either way. You could say like, you know, 51 was pretty low compared to these other ones. Or you could say, this is what I would say. I would say, well, there's the numbers are like 50s, 60s, 70s, 80s. They all seem pretty close together. And so I say that the mean is better on this one. So let me just explain the test a little bit. Whenever there's a problem on the test and we don't necessarily agree, or even on here, if you have a good explanation, then, you know, I'm happy to consider other answers. So if you're sitting here and you're like, I played high school basketball, 51 is way different than 59. Okay, tell me about it and explain. But just looking at this list of numbers, I don't think 51 is that far off of the list. So I'm going with median. And really, this is a non-issue because by like the next video, you're going to have an actual definition of outlier. So you would actually be able to calculate whether or not 51 is an outlier. So, all right, so that is it. Make sure, like the least you should know by the end of this is how to start using your calculator. If you have a graphing calculator, email me and I can send you paperwork regarding a TI 83, 8045 that works for those. I also had a colleague make a bunch of YouTube videos for a bunch of different types of calculators, so I can share that if anyone's interested. Otherwise, it's my favorite. I love this one. It's the best. So hopefully you have something similar. All right. Email me if you have any questions.